I want to now talk about this mini case that I described earlier, which is applying portfolio theory to rare disease portfolios. So I want to start with a little bit of a definition about what I mean by an orphan disease or rare disease. Those two things are used interchangeably, but I don't think that that's accurate, so I want to be very explicit with what I mean. An orphan disease is, by definition, a disease that affects 200,000 patients or less in the United States. Where I'm getting that from is the 1983 Orphan Drug Act. This was a piece of legislation that was passed by Congress in order to get more focus on developing therapies for these smaller diseases, diseases that affect smaller patient populations. So examples are sickle cell anemia, currently estimated in the United States to be about 100,000 patients, or glioblastoma, a kind of brain cancer that affects roughly about 100,000. These numbers are very, very rough, so don't sue me if I don't get them exactly right. They change, obviously, depending on lots of different things. Cystic fibrosis, 30,000 patients. Lou Gehrig's disease, ALS, 30,000. Gaucher syndrome, a rare genetic disorder, 6,000 patients. Hemophilia, 20,000. Duchenne muscular dystrophy, 7,000. And then you get into some of the ultra-rare diseases. These are diseases that affect maybe hundreds of patients. One example is PNH, paroxysmal nocturnal hemoglobinuria. It's a blood disorder that affects maybe, it says here about 1 to 2 per million, a very small number of individuals, probably 300 to 400 in the United States. It's a particular disorder that prevents your blood cells from producing a certain surface protein, and so your own immune system starts to attack your blood cells, and it happens most frequently at nighttime. So occasionally you will wake up and your urine will be the color of Coca-Cola. It is obviously very distressing. It causes fatigue, all sorts of problems with various aspects of your body and organs. And by the time you're in your 20s or 30s, you're usually dead of this disease. Now, dealing with the disease is a challenge, but even diagnosing it, if you've got 300 or 400 patients in the United States that has a disease, we have, 320 million people in this country, you can imagine that your local doctor, unless your local doctor happens to be at Mass General or at the NIH, is not going to know about these diseases. Things have changed quite a bit over the course of the last decade or so, but certainly before then, these diseases, never mind therapies, they weren't even getting diagnosed because they were so rare. We just didn't know what they were. But when you combine all of the different rare diseases out there in the US, it turns out that there are 25 million Americans that have one or another of these diseases. That's more than the number of people that have cancer. So while they're rare by themselves, they're obviously a much bigger problem when you look at it from a broader perspective. And about 80% of them have to do with rare genetic defects. These are typos in your DNA that happen either you inherit them or they happen during the course of your lives. And as a result, we actually now are in a position to be able to diagnose them, whereas before we sequence the human genome, it would be virtually impossible to really be able to say much about the underlying genetic origins. But we can do that now. And since the 1980s, when the Orphan Drug Act was enacted, there are a number of therapies for these terrible diseases. Currently, as of a few days ago, 596 FDA-approved orphan drugs. So an orphan drug is a drug that was approved under the Orphan Drug Act. And the reason I'm being so explicit about that is because an orphan disease is not the same thing as a rare disease. And the difference is that recently, thanks to the ability to use genetic biomarkers, we can stratify patient populations into smaller groups of less than 200,000. And so now all of a sudden, a disease that was very prevalent, like breast cancer, 230,000 cases diagnosed every year, 30,000 women die of it every year. Breast cancer is not a rare disease. But because we can now figure out those women that have certain genetic mutations that will allow us to treat their particular disease with Herceptin, Herceptin was approved as a rare disease drug, as an orphan drug. And the reason that's important is because orphan drugs have certain economic advantages that I'll get into shortly. So the orphan designation in particular gives a number of features, economic features, to the drug companies that propose them. For one thing, according to the Orphan Drug Act, you get tax credits up to 50% for your clinical testing costs. You have authorized expedited review. So in other words, you get to the front of the line at the FDA. You have a 7-year period of marketing exclusivity. Now, I want to explain what that means. When you have a patent for a drug, that means you have a monopoly for 20 years. Only you can use the patent for those 20 years. If anybody else wants to use it, they have to pay you for it, right? But other people can develop other patents while your patent exists. There's nothing that says that they can't invent new drugs. Well, the Orphan Drug Act of 1983 says something stronger. It says if you get an orphan condition, or an orphan drug approved for a particular condition, the FDA will not even review any other competitors for 7 years after your drug gets approved. So you have an exclusive for 7 years, above and beyond the patent. They can't use your idea, but in addition, they can't get the FDA to approve any other idea for this orphan disease for 7 years. That's extra protection for your revenue stream. And there's also significant pricing power as a result, because within those 7 years, you can price however you like, and nobody's going to be providing any competition for you. By law, the FDA cannot even review another drug for your indication for 7 years. You see how that works? It's pretty valuable stuff, right? And finally, for certain kinds of rare diseases, tropical rare diseases, infectious diseases, and for pediatric rare diseases, the FDA will provide something called a PRV, a priority review voucher. If you get orphan designation for a particular disease for which you are developing a drug, and you get the approval of the FDA to go forward with that program, they give you orphan drug designation, and it happens to be for a pediatric rare disease, then on top of all of the goodies that I just described, you'll get a piece of paper that says you will be able to get this drug reviewed. Instead of in the typical 12 months, we will promise to do it in 8 months. Now, there are two things about that priority review that you have to know. The first is that it's not free. You have to pay the usual costs for undergoing priority review, undergoing regular review, plus you have to pay an extra $2.7 million to do the priority review. Now, why is that a good deal? Well, it's a good deal for at least two reasons. One is that the reason the FDA added that extra $2.7 million is they did not want this program to implicitly slow down other programs. And so it doesn't. And the way that they assure that it doesn't is that the extra $2.7 million that you pay for, that's going to allow them to hire extra staff to take on this particular priority review. So nobody else is getting slowed down, but you are providing the extra resources for the FDA to be able to hire people to do the review. That's the one advantage. The really big deal is that you get to sell the PRV once to somebody else for any other possible use at all. Do you understand that? In other words, you apply to develop an orphan drug for a pediatric rare disease, and they give you this piece of paper that gets you to the front of the line, 8 months review for an extra $2.7 million payment. And that's your piece of paper. You can use it, or you can just give it to somebody. Well, you wouldn't give it to somebody. You'd probably sell it to somebody. And how much do you think it's worth? 4 extra months? What's the big deal? How could it be worth much of anything? Well, the most recent PRV, there have only been 6 or 7 of these out there and sold. Some of them have sold for a lot of money. Some of them have sold for not so much money. The most recent sale occurred just recently, back in February 27th, just last week. It was sold to Gilead, the maker of the hepatitis C drug, Sovaldi and Harvoni. It was sold to them by Sarepta, a local company just a few blocks away, who had developed a Duchenne muscular dystrophy drug, which is why they got this PRV. They sold it to Sarepta for $125 million. One piece of paper, $125 million. And that is not the largest sale. I think the most expensive PRV was sold for about $350 million. But it looks like the market prices are coming down, so now it's only going for 125. Now, why are we doing this? First of all, who did this? The FDA did not come up with this. And I'm told that the FDA is not a big fan of the PRV. They would just as soon not have to deal with it. It wasn't their idea. It was actually proposed by an economist, a couple of economists, who thought that this would be a good way to incentivize drug developers to deal with less popular diseases like infectious diseases, vaccines, and so on. And so the original PRV was for tropical diseases. But it caught on, and the reason that Congress decided to pass this PRV legislation to allow the pieces of paper to be sold is because their view is that you can either use it, or if you can sell it, that will give the drug developers more financing to be able to develop drugs for rare diseases. It will help the cause. And so Sarepta now has $125 million that they otherwise wouldn't have to be able to use in various different applications. That's the logic behind it.